Here we have a SAT math problem. Okay, let's go to the question. The function f is defined by f of x equals to x to the third power negative ax square cos to bx negative 4, where a and b are constants. In the xy plane, the graph of f intersects the x-axis at the 3 points negative 1, 0, negative 2, 0, and k, 0. What is the value of k? Since f of x equals to a cubic polynomial, we can have a maximum of 3 linear factors for this cubic polynomial. Since the graph of f intersects the x-axis at 3 points, that is, we have 3 x-intercepts for the graph of the function f of x, we have 3 linear factors for this cubic polynomial. To get those 3 linear factors, what we have to do is we have to consider the given x-intercepts. Okay, now let me consider the first x-intercept over here, that is negative 1, 0. From this x-intercept, we can get a linear factor. For that, we have to consider the x-coordinate over here, that is negative 1, x equals to negative 1. Now, to get the linear factor corresponding to this x-intercept, we have to make the right side 0. For that, we have to add 1 to both sides of this equation. Then I'm getting x positive 1 equals to 0. This is a linear factor corresponding to the first x-intercept. In the same way, we can get 2 more linear factors from the other 2 x-intercepts. Okay, now let me consider the second x-intercept. Here the x-coordinate is negative 2, that is x equals to negative 2. Make the right side 0. For that, we have to add 2 to both sides of this equation. I am getting x positive 2 equals to 0. This is the linear factor corresponding to this x-intercept. Now let me consider the third x-intercept, that is k, 0. Here the x-coordinate is k, that is x equals to k. Make the right side 0. For that, we have to subtract k from both sides of this equation. Then I'm getting x negative k equals to 0. Okay, here I got the 3 linear factors of this cubic polynomial. So they are x positive 1, x positive 2, and x negative k. Now we can write this cubic polynomial in factor form. Okay, let me write this polynomial over here. X to the third power negative ax square positive bx negative 4. To get the factor form of this cubic polynomial, we have to multiply the 3 linear factors we have over here. Okay, let me write it. That is x positive 1 times x positive 2 times x negative k. Whenever I write a polynomial in factor form, I must write some number over here. So this number has to be the leading coefficient. In this case, the leading coefficient is the coefficient of x cube over here, that is 1. And also when I multiply the first terms in all the 3 linear factors over here, that is x times x is x square times x is x to the third power. So this is the leading term we get on the right side. So the same leading term we have on the left side as well, that is x cube. So then we must have the number 1 over here, so that I'll be getting the leading term x cube on the right side, the same we have on the left side over here. But writing 1 over here is not required, because even when I multiply all these stuff by 1, still I'm getting the same stuff. So 1 is not required. Okay, here the polynomial is equal to the product of 3 linear expressions over here. Since this polynomial is equal to the product of 3 linear expressions, the constant we have on the left side over here must be equal to the constant we get when I multiply the 3 linear expressions. Okay, let me consider the constant on the left side over here, that is negative 4. Now to get the constant on the right side in the product of these 3 linear expressions, we have to multiply the constants over here, positive 1, positive 2, and negative k. Positive 1 times positive 2 is positive 2. Positive 2 times negative k is negative 2k. Okay, now let me divide both sides of this equation by negative 2. Here this negative 2 will cancel out. Negative will cancel out. 4 divided by 2 is 2. On the right side we get k. Okay, here I got the value of the constant k. It's 2.